Hello students, welcome. In this video, we will be dealing with K-map, Carnot map, to simplify Boolean expressions. So now before we get into the rules of simplification using K-map, let's do a problem. Here is an expression that is said. The first term is A dash, B dash, C dash. So that is 0, 0, 0. The second term is A dash, B dash, C, that is 0, 0, 1. We have to represent the same in this K-map. So we represent the first term 0, 0, 0 over here in this cell 0, 0, 0 over here with 1. The second term 0, 0, 1. So that is 0, 0, 1. So over here we represent using 1 bit. All other cells in the K-map are placed with a 0 bit. Now we group the 1 bits either horizontally or vertically. So we group those 2 bits over there. Now we write the simplified form, that is z is equal to, now for these both the bits, what is common? That is 1 is 0, that is a naught. What else? B naught, that is 0, 0 is also common here. So what about C? C is not common. So this is a simplified expression. Before going to simplify more Boolean expressions, let us now see the rules to work with K-map. The idea is to group the adjacent cells containing ones in the case of SOP, and the adjacent cells containing zeros in the case of POS. Let us now see the rules as per SOP, sum of products. So the first rule is group only ones in the case of SOP and zeros in the case of product or sum. So this is how we group it. We cannot mix zeros and ones together. And the second rule is we group either horizontally or vertically. You cannot group diagonally. And the third rule is group must contain 2 to the power of n cells. That is either 2 cells or 4 cells, 8 cells, like that. You cannot have 3 cells or 5 cells in the group. Then each group should be as large as possible. You cannot have smaller groups when larger groups are possible. And next rule is each cell containing a 1 must be in at least one group. No one bit should go ungrouped. It should be part of some group. And of course, the groups can overlap like this. Okay, we should overlap them whenever it is required. Then groups may wrap around the table horizontally or vertically. Now think of this table as a piece of paper. Now if you can fold them horizontally, the ones on the edges can meet, can become a group. Or if you turn them vertically, fold them, the ones on the top and bottom can come together as a group. So that is possible too. And finally, there should be as few groups as possible as given here. So these are the overview of all the rules to work with to simplify using K-map. Now let us move to simplify more Boolean expressions using K-map. Now let us solve this Boolean expression using K-map. In this Boolean expression, there are 4 terms. Let us represent each term in the K-map. The first term is A dash, B dash, C dash. That is 0, 0, 0. So the first term is represented at 0, 0, 0 over here. The second term is 0, 0, 1. A dash, B dash, C. So 0, 0, 1 over here. Third term is 0, 1, 0. That is 0, 1, 0 over here. And fourth term is A, B, C dash. That is 1, 1, 0. So 1, 1, 0 over here. Now we fill all other cells with 0. Now we group the ones either horizontally or vertically. So all the ones have been already grouped. Now let us see the final simplified Boolean expression. So z is equal to, okay, we consider the first group. Over there, the common element is A dash and B dash plus the second group. Over here, what is common? What is common? A is not common. B and C are common. So that is B, C dash. So this is the simplified expression for the given Boolean expression. Now let us simplify one more Boolean expression using CAMAP. Now this is the Boolean expression with 4 variables. So when there are 4 variables, there should be 2 to the power of n cells in the CAMAP. That is, n is 4, so 2 to the power of 4, that is 16 cells in the CAMAP. So here are 16 cells in this CAMAP. Now let us start representing each term which is given over here. The first term is 0, 0, 0, 0. Next term is 2, and next term is 5, and comes 7, and there you have 8 over here. Then we have 10. Next one is 13, and finally we have 15. So 8 terms have been represented in the CAMAP. Now let us group the ones. So this would make one group, and the next group, if you look at the edges, you have one element over here, another element over here. If you fold the paper horizontally, it will make one group. Also, we have another element on this edge and yet another element on this edge. Now, if we take the rule to fold horizontally and vertically, all those 4 isolated ones will make one group of 4 ones. So we have got 2 groups of ones over here. Now it's time we write the simplified expression of the given Boolean expression. So the simplified expression is f is equal to the first group. What's common for all these 4 ones? What about P? P is not common, but Q is common. R is not common, but S is common. Plus, what about next group? What is common? So if you take it as one group, P is not common, but Q is common. P is not common, but Q dash is common. Q dash. Now R is not common for them, but S dash is common for all those elements. So S dash. So this is a simplified expression of the given Boolean expression using CAMAP. When it comes to max terms or product of sum, you have to group zeros instead of 1 bits in the CAMAP to reduce or to simplify the Boolean expression. Thanks for watching. Happy learning.